Okay, so I should be recording. It looks like I am. This is a 4.3 properties of logs. Um, one of the more difficult problems, so that's why I said that I wanted to record this if I can find it. Technically, we just didn't really have time to devote what we needed to this problem. So let me just go ahead and start it now. If you have a problem on your homework that says 1/6, right? So 1/6. Let me make sure y'all can actually see what I'm doing here. Thing kind of got away from me there though, didn't it? There we go. 1/6. And then say you have a bracket, 5 natural log open, x plus 2 close, a negative natural log x, a negative natural log open, x squared negative 16 close, and then close your bracket. So already like that problem's all over the place, right? You're just going to actually individually look at what you can on the inside and figure out what can be applied. And then once you've simplified that as much as possible, then that's whenever we'll kind of look on the outside and see like, okay, what does this 1/6 mean, right? Okay. So what I notice first is that if there's a problem that is being added, right? I've got multiple natural logs or multiple logs being added, then that's going to imply multiplication, right? If they're being subtracted, that means I'm going to divide them. So the way this problem looks now, just initially, I've got my minus sign here, I've got my minus sign here. So it would almost look like that's the numerator, this is the denominator, and then there's another denominator. Like, no, we're not gonna like divide by a fraction. That would get really ugly, right? So instead, just look at these two terms. I'm working this way, okay? This is 1/6 times 5 natural log of x plus 2. And then look at right here. This is a term and this is a term. They both have a negative sign, which is technically like their greatest common factor in a way, honestly, right? I know that for a fact I can pull that negative out. And now let me look at it. If I do that, what I have is technically this is a -1, right? I divide everything by the GCF. Natural log of x divided by -1, what happens is the signs change because negative divided by negative would give me a positive. And now scoot over to this one. The same train of thought, this whole term right here, I'm really just looking at the negative divided by the negative. That makes it a positive, right? Now this looks a little bit better because this is saying that I'm going to have this in my numerator and then I'm going to have this in my denominator. It might still be a lot that's going on inside of there, but if you look, it's multiplication because this is an addition sign. I can have something multiplying inside of the denominator. I just wasn't fixing to try to have like, multiple denominators, right? So now let's move on. Go a little bit further here with this. Okay, so what I'm going to notice here is I have a 1/6. I'm going to go ahead and open up my bracket. I see that this is a coefficient, which means it can be made an exponent, right? Let me go ahead and write natural log of x plus 2, close, raise it to the 5th power. Then I'm going to subtract from that. Okay, hold on. So let me look. You remember how I was saying that this addition sign means that it can be written, like these two terms can be written as multiplication? So the way you would write that as multiplication is we would have our natural log and then multiplied by these two terms, right? My x times this. So I get my x and then times x squared negative 16. Y'all, the reason for all the different parentheses is because it's not just like x times 3 or x times y. It's x times and then this binomial, okay? So make sure that you just separate it that way. And then let's go ahead and close our bracket. Okay, now moving on. I would actually, at first, I would think, should I distribute that? It really doesn't matter. This is saying two terms are multiplying each other. And so that's all I really need to show that it came from an addition problem, right? So now what I care about is this negative sign means this is the numerator, this is the denominator. Let me arrange it as such. 1/6 times, right? Like these are multiple natural logs. My goal is to get it to one natural log. Here I had 2, I condensed it to 1. Here I have 2, I'm going to condense it to 1. So natural log. And then because of this subtraction sign, right, that's my division. That's my fraction bar right here. This is numerator. Because there's a power on it, y'all make sure that you carry the parentheses with it everywhere, right? And then this is my denominator. And because it's in the denominator alone, I no longer have need for all of those parentheses. I really just need that set on this binomial right here, and close that. And then I notice that this, okay, so this has basically been condensed as much as possible, right? I don't have any other rules that I can mess with here, but I do notice that this is a coefficient, even though it's a fraction, it's still a coefficient multiplying this. So what coefficients do is they become powers, right? Coefficient to a power. So I'm going to make this, ooh, oh, I missed, ooh, right here. That's my power right there, right? Let me rewrite this. What I get is this, which is natural log of, okay, it's going to have a power, right? So put your parentheses, do your fraction bar, x plus 2 to the 5th over x times x squared, a negative 16 close the big one. I have a 1/6 power. Sorry, but I love this classroom. I can actually write in pencil. Like everything's clear. I love it. Okay, so now you think, okay, I must be done because this problem's taking forever. You're actually not done just yet. That exponent rule, which states if you have something, right? Not even really just a variable, because I'm obviously this is a bunch of something, but this is acting as my a. If you have something raised to a fractional exponent, your denominator is your root and your numerator is your exponent on your something, on your a, okay? This is what's happening here. This is something raised to a power that's in the form of a fraction, turn it into this. This is going to be a more simplified way of writing it. And so if I could scoot up, what we get is natural log. Let's use this. Denominator is your root. 6th root of a. This is my a. This whole thing is my a. My m comes from the numerator. That's 1. So, I mean, there's no reason to write the exponent of 1, right? So technically, all you need to write is this under here, which is in parentheses x plus 2, close, raise it to the 5th, open, x, I said open, over x, open, x squared, negative 16, close. Yeah, done. That's it right there. And we can go backwards. If this is what we started in, this would be a problem that would probably say condense, right? It's big, it's crazy, make it smaller. This would be a problem that would say expand. It's small. The way you know it, multiple natural logs means get down to 1. If you start with 1 log, okay, well, you're eventually going to work your way into multiple logs. Excuse me. This one, I would recognize there's a root. Let's make that a fractional exponent. Okay, I did that. Okay, well, this fractional exponent is a power. Let's make it a coefficient. Okay, I did that. Then I would notice, hey, division's going on here. Let's subtract the numerator from, the numerator and the denominator, right? Subtract them from each other. Then what I would notice here is that this is multiplication. It can be written as a sum of the natural log of both of these terms. And I noticed that my exponent right here can become a coefficient. And then now I'm here. What I would notice here is that personally, even in my own mind, I would be like, oh, I'm good here. Distributing the negative would just be like an intermediate algebra type of thought process that, anytime you have a negative touching a parenthesis, you always want to change the signs inside. But either I would accept. So that's like the last problem-ish, maybe around so of the homework. And I just wanted to make sure that y'all would be able to solve it. Other than that, that's it. Bye, y'all.